Modern oil and gas pipeline production process. Oil and gas pipeline installation. Oil and gas are now generated over almost every area of the planet, from the Arctic to the Antarctic. Private wells range from 100 barrels per day to 4,000 barrels per day. Wells ranging in depth from 20 meters in shallow reservoirs to 3,000 meters in deeper reservoirs. More than 2,000 meters of water, $100,000 onshore wells, and $10 billion in total offshore construction. Amidst the variation, many aspects of the procedure are similar. In theory, they are quite similar. What is oil and gas production? Oil and gas production is the broad-sense method of extracting oil and natural gas from wells and converting them into usable petroleum products. Oil and gas production involves a series of steps, beginning with browsing and ending with a supply chain to businesses and the public at large. President Joe Biden of the United States, the world's major oil and gas manufacturer, declared in March 2022 that, in addition to promoting increased domestic oil exploration, the country will release 1 million barrels per day from its strategic petroleum reserve to help lower national prices. Process of oil and gas production. The oil and gas extraction process is broken down into 3 major stages: upstream, midstream, and downstream. Each phase is controlled, and laws vary by municipality or condition. There are also treaty obligations that must be witnessed and followed. Stage 1. Upstream. The primary process of oil and gas production, which includes exploration, drilling, and extraction, is referred to as upstream. Exploration. This is the first stage, during which geologists and other industry experts look for rocky outcrops or regions where oil and gas are frequently found. Following the selection of a site, it will be primed and established for the real production chain. Drilling. The well drilling process and time frame can vary based on the methods and equipment in use. It usually takes 2 to 4 weeks, but drilling an offshore well can take several months. Oil and gas are frequently drilled vertically, but using innovative techniques provided numerous benefits such as time savings, lower operating costs, and less environmental harm. Horizontal drilling, multilateral drilling, extended reach drilling, and complex path drilling are examples of new drilling techniques. Extraction. The method of extracting traditional oil and natural gas from groundwater, aquifers, and wells is referred to as oil and gas extraction. This is also the stage at which fracking and fracking fluid recycling takes place. Stage 2. Midstream. Midstream involves the processing, storage, and mass transit of oil and gas products as the secondary stage. Processing. This is the midstream phase where oil and natural gas are divided before being transmitted to petroleum refineries to eliminate unwanted products and non-hydrocarbon gases. Storing. Appropriate product stockpiling is critical to meeting both domestic and international demand, preventing shortages and disparities in supply, and ensuring the safety of all employees and folks who work in the industry. Natural gas is generally contained in buried rooms, such as fractured reservoirs, whereas completed oil products, crude oil, and refined oil are frequently saved in above-ground reservoirs. Transportation. Mass transit is the company's all-encompassing procedure. It begins with the extraction and transportation of oil and gas to processing facilities, then to businesses and organizations across the country and to other countries, and eventually to the wider populace or primary customers. Unrefined oil is transferred via tankers and pipelines, whereas finished petroleum products are transported via trucks, railroad cars, tankers, and additional pipelines. Stage 3. Downstream. Downstream means the third and end phase of refined petroleum refining and allocation. Refining. Refining is the way of transforming crude oil and natural gas into final oil products that can be used for a variety of purposes, including public transport and electricity fuels, asphalt and road oils, kerosene and raw materials for the production of plastics and synthetic materials. Several processes are also involved in oil refining, based on the final end product. Distillation, cracking, coking, reforming, and post-treatment are common units in this process. Distribution. Distribution, as the name implies, is the final step in which completed petroleum products are transferred and dispersed to businesses, government agencies, and the general public, which includes industrial customers, electrical providers, and residential and commercial heating, among others. Oil and gas pipeline installation. Putting a pipe on the seafloor can be difficult, particularly if the water is profound. Subsea pipe is laid in 3 ways: S-lay, J-lay, and towing, and the pipe-lay vessel is critical to the installation's achievement. Buoyancy has an impact on the pipe-laying procedure, both positively and negatively. When stuffed with air, the pipe evaluates less in the water, putting less strain on the pipe-lay vessel. However, once on the seafloor, the pipe necessitates an induced drag to maintain its position. The weight of the oil getting passed through the pipeline can accomplish this, but gas does not weigh enough to maintain the pipe from veering across the seafloor. In shallow water, concrete is laid over the pipe to keep it in place, whereas in deep water, the amount of insulating material and thickness needed to withstand hydrostatic pressure is usually sufficient to keep the line in place. Tow-in pipe installation. While hoops are usually brief, sufficient to be placed in segments by ROVs, flow lines and pipelines are appropriate for the age enough to necessitate a different type of installation, such as tow-in, S-lay or J-lay. Tow-in installation is exactly what it sounds like. The pipe is stopped in the water via buoyancy modules, and 1 or 2 tugboats tow it into position. When the pipe arrives at its destination, the buoyancy modules are excluded or flooded with water, and it floats to the seafloor. Tow-in pipeline setup can be classified into 4 types. The exterior ride entails pulling the pipeline on the top of the water. A tug drives the pipe on top of the water in this method, and buoyancy modules assist in keeping it on the water's surface. The mid-depth tow, which uses fewer buoyancy modules than the surface tow, uses the forward speed of the tugboat to keep the pipeline sunk. When forward motion ceases, the pipeline sinks to the seafloor. Off-bottom towing employs buoyancy modules and chains for additional weight, which work in tandem to keep the pipe just above the seabed. When the pipe arrives at its destination, the buoyancy modules are excluded and it settles to the seafloor. Finally, the bottom tow pulls the pipe along the seafloor without the use of buoyancy modules. This type of setup is only conducted in shallow water and requires a soft and flat seafloor. Installation of a S-lay pipeline. Pipe is loosened off the transom of the ship as the boat moves forward during the S-lay pipeline setup. From the stern, the pipe contours downward through the water until it reaches the touchdown point. It's its ultimate stop on the seafloor. The pipe forms the shape of an S in the water as more pipe is welded into the line and eased off the boat. Stingers extend from the stern and can be up to 300 feet, 91 meters long, supporting the pipe as it is moved into the water and controlling the curvature of the installation. Some pipe-lay barges have adjustable stingers that can be shortened or lengthened based on the depth of the water. Tensioning rollers and a controlled forward thrust keep the pipe from buckling during the S-lay process. S-lay can be done in waters up to 6,500 feet, 1,981 meters deep, and it can install up to 4 miles, 6 kilometers of pipe per day. J-lay pipeline installation. By implanting the pipeline in an almost vertical position, J-lay pipeline installation overcomes some of the challenges of S-lay installation. Pipe is lifted and inserted into the sea via a tall tower on the boat. In contrast to the double curvature obtained with S-lay, the pipe curves only once in J-lay installation, taking on the shape of a J underwater. J-lay can work in deeper water depths due to the reduced stress on the pipe. Furthermore, the J-lay pipeline can withstand more motion and underwater currents than the S-lay pipeline. Types of pipe-lay vessels. Pipe-lay vessels are classified into 3 types. J-lay and S-lay barges have a welding station and a lifting crane on board. In an enclosed environment, the 40 or 80 foot, 12 or 24 meter pipe sections are welded away from wind and water. Pipe is laid one section at a time in these vessels using an assembly line method. Reel barges, on the other hand, have a vertical or horizontal reel around which the pipe is wrapped. Reel barges can install both small diameter and flexible pipe. Horizontal reel barges install S-lay pipelines, whereas vertical reel barges can install both S-lay and J-lay pipelines. When using reel barges, pipe sections are welded together onshore, lowering installation costs. The pipe is lifted from the dock to the vessel and simply rolled out as installation is completed. Once all of the pipe on the reel has been installed, the vessel either returns to shore for another, or some reel barges have cranes that can lift a new reel from a transport vessel and return the spent reel, saving time and money.